Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome back to my channel. In today's video, we are going to explore new ways of how to create custom contracts using thirdweb's new tool, ContractKit. Please note that this video is for educational purposes only, and as an educator in the space, it's my duty to share with you these awesome tools. thirdweb really makes it easy for you to become an end-to-end Web3 developer. And that is pretty cool. With all the SDKs and stuff that we can use, and they make it super easy for you to deploy on chains such as Ethereum, Polygon, Solana, Binance, Avalanche, and so much more. It is really like this one-stop shop, and I think by making some of the videos, you will understand how to use the tools. Talking about making videos, I already have made some videos in this playlist. It's called thirdweb with HashLips. So, if you go here, I explain the basics such as using their dashboard and an easy way how you can deploy NFT contracts with a few simple clicks. The reason why I'm mentioning this is because this video will form part of this series. Now there are some prerequisites that you need to understand for today's video. To understand our prerequisites and dependencies, we need to see what we are going to build. Today, in this video, I'm going to show you how to create a custom smart contract using the ContractKit. And we're going to add some custom logic. However, seeing that this is an NFT contract, we will need some images and metadata. The images and metadata will look something like this. We have some images, as well as a metadata file containing more information about each of these images. This whole set will be uploaded to a decentral storage using thirdweb, but first we will need this information. And to get that, you can make use of the HashLips art engine. And to simplify the process, and this is why I'm showing you the series, all you need to do is watch number 2, 3, 4, and 5. And this will get you geared up and also have you produce images and metadata in no time. So the images and metadata are really a little dependency for this video. In the next video, we are going to take this concept further, using thirdweb's SDK for React, as well as the UI components, and build out a minting dApp. It's going to be amazing, because I'm also going to show you how to interact with our custom logic. Make sure that your operating system has a version of Node.js installed. You can simply install it for your operating system, as well as an IDE, a code editor. I am using Visual Studio Code. It is free and a wonderful IDE to use. The process that I'm about to show you is very straightforward and simple. However, if you do get stuck, feel free to go to the HashLips.online website, click on the Discord icon, and join a server full of individuals that's willing to help you out. The thirdweb team also has a channel in the HashLips server. Alternatively, you can always go directly to thirdweb's Discord as well. Now, let's get started. The technology we want to use is called ContractKit. So on thirdweb's website, go to Products, and here we can click on ContractKit. This will give us a nice overview of what ContractKit actually is about. This diagram explains it very well. ContractKit is a plug-and-play solution to fast-track your development. And what I mean by that is actually you get to create a contract either from scratch or a custom one, or you can base it off one of their templates. In this case, an ERC 721 base template, and then you get to decide what kind of added features you want to add on top of it. What makes it great is that if you use ContractKit and thirdweb's extensions, you can actually directly use their interface later on as well, and I'll show you that too. So we are going to see how fast we can create a contract. And on top of it all, the way that thirdweb deploys their contracts never require the user to reveal any private keys, which I think is phenomenal. Click on this button Get Started, and this will take us to the ContractKit's documentation. The documentation is very well structured, and you can go ahead and see what base contracts, extensions, or even interfaces you can use. Now, if I don't cover everything today, you can go ahead and look for yourself which extensions you want to play around with. Moving forward in the overview section, we can scroll down and see there's two ways that we can actually implement this. We can either go ahead and, if we have an existing Solidity project, go and add the contracts themselves, or we can use the CLI for us to create a new project, which we are going to do. For the next step, if you know what you're doing in development, you can go ahead and use the terminal. In my case, I'm going to use the Visual Studio Code to make it easy for non-coders to follow along as well. Open Visual Studio Code and click on Open. We want to go to our desktop and just simply open your whole desktop. I can see all my files over here. Next, I want to make sure that at the top, click on Terminal and select New Terminal so that a terminal down here pops up. This is where we will enter the commands. We can close this open page. The reason why I'm going to my desktop is because by using the thirdweb CLI, it will create for us a folder, which we will then reopen in Visual Studio Code. So, now that you know that your terminal is in the desktop, we can go back and copy this command. npx thirdweb create -- contract. Open Visual Studio Code, paste this in, and hit enter. If this is the first time that you are running this command, it will ask you to install the thirdweb CLI. So just say yes, and then when you run this, it will create this contract for us. The thirdweb CLI will open up, and now we can see a beautiful text and some questions. The first question is, what is the project's name? So we need to enter something in here. Seeing that the images that I'm going to upload is eyes, I'm going to call this my -- contract. So I'm going to just say enter. And now it's going to ask me what kind of framework do I want to use. You can use either Forge or Hardhat. I prefer using Hardhat, so I'm going to hit enter. And now we get to decide what kind of contract do we want to start off from. We can go for an entirely empty contract and code it all from scratch, or we can go ahead and select one of these standards. I am going to select ERC 721. At this point, we get asked what extension we would like to add to our contract. And if you go to the documentation and you head over to the ERC 721, here are some of the extensions and basically the base contracts that you can start off from. Now I want to go for the drop, and the reason is it incorporates all these features. And if I do this, I will be able to utilize the thirdweb interface later on as well. Plus, this is a nice contract to start off from. So back in the code, I'm going to head down to drop and hit enter. The thirdweb CLI will then go ahead and construct the contracts as well as installing all the dependencies. Once it's done, we will be notified that it is complete, as well as be informed about some of the commands that we can run. Here in my desktop, I can see the iContract folder now created. The following commands, yarn build, yarn deploy, and yarn release, can only be run inside of the iContract project. This one over here. We will go and reopen this in Visual Studio Code in just a second. However, let's take a look at these. Yarn build will go ahead and compile your contracts and detect thirdweb extensions implemented on them. This is a great way to see what the SDK later on can interact with. Also, we can deploy it with thirdweb's flow, and that is very cool. The yarn release you won't really use now, but I'll make a video on it later. It's basically how you can create cool templates. Now let's go ahead and reopen Visual Studio Code inside of the iContract project. In Visual Studio Code tabs at the top, click on File, click on Open, and then just simply select this folder. I'm now going to open this in the actual project. The reason is, if I go to my terminal and click on New Terminal at the top, we can now see that the root is sitting inside of this project. Now we can go ahead and test out that build command. I'm going to type in yarn build, and when I hit enter, notice what will happen. This will open the CLI and start adding a cache file and some artifacts. This is now compiled and also picked up which dependencies or basically extensions we have in the contract. This build step is really cool because you get to double check and make sure that you have the right extensions on your contract. Now, technically, this is ready to deploy as is. And if we go ahead and deploy this, we can deploy an NFT ERC721 drop contract using the thirdweb flow, simply by typing in yarn deploy. But this video is about how do I customize this existing contract. So let's go and customize this and add our own logic before we build and deploy. So how would we go ahead and edit this contract? Well, taking a look at the folder structure, it's purely a node application that the CLI has created. The most important folder is this contracts folder over here. There is a contract.sol. Now in here we can go ahead and add our custom logic. As we can see that we are already importing and is using the ERC721 drop extension. We can add more extensions from thirdweb, or we can also add some custom logic, which we are going to do right now. Like I said in the beginning of the video, the custom logic we want to implement is a way for an owner of an NFT to write a small message to that NFT. Now, a way for us to do that is to actually keep track of the NFTs by ID and then associate an ID with a little message. So let's start off by adding a mapping. And this mapping would be a uint 256. And this is going to be to string. Once we have this, we need to make sure that this is an indeed public, and we'll call it the notes. Now we have our mapping set up. The next thing we'll need is some sort of function, and we can probably call this function write note. And this will take in the uint 256, and we are going to call this is the token ID that it needs to take in. The next is actually a string, and for strings we need to use memory, and this will be our message. The function will be a public function, and then we need to make sure about a few things. The first thing is we need to identify that the person trying to write a note to this index is indeed the owner of this token. For that, we can actually implement a safeguard check using a require statement to check if the message.sender, the person executing this transaction, is actually equal to the owner of. Now, this owner of function exists on the ERC721 standard, so it should technically be there. And we're going to see if the token ID, if this person is indeed the owner of this queried token ID. And if they are not, we need to maybe leave a message saying you are not the owner of this token. And now that we are sure that this person has to own this token in order to write a message, we can simply say that our note followed by the token ID, we're going to set this message equal to this new message that the user has. Now, I would recommend if you do something like this on the blockchain to add extra checks to maybe make sure there's a character limit and all these sorts of wonderful stuff. For this demonstration purpose, this is fine. This is a fantastic example of how you can add some custom logic using ContractKit. But what if we want to extend this contract and use extra permissions? maybe we want some kind of moderator role for someone to overwrite these notes. So what we can do is basically copy this function. Let's go ahead and change this to override note, and then let's take away this require statement. At this point, anyone will be able to overwrite the note. But what we want to do is give someone the ability with a specific role and permission to do this. Let's see how we can implement it. One way we can simply do that is just by using the ownable permission that we already have on this existing contract. However, maybe you want someone else to do the moderating. So, in that case, let's go ahead and import the permissions extension. In the documentation, we can go down to the extension section. Here, underneath access control, we have the permissions extension. We can go ahead and copy the import and import this in our code. Then let's go back and read how we can implement this. As we are going down in the documentation, it's also important to note the fact that we are now using a thirdweb extension means that we unlock the permissions control feature that we can later on use with the SDK. It's pretty cool. And implementing this, we simply have to import the extension, and we have done that. And then we have to extend our contract. So add the permissions over there. Now for the implementation. A good way that I like to make sure about functions in contracts is holding Command, hovering over the actual contract, and clicking on it. This will bring us to the actual implementation of the contract, and what we can see here is that there's something like a default admin role. We can just use that role for now. And there's also a modifier called only role. So what I'm going to do is go back to our contract and add the modifier over here. We're going to say we want to have only the role of the default admin be able to update this note. Keep in mind that the default admin role is initially assigned to this. So we need to update this in our constructor as well. As we can see in the documentation, here we can see in the constructor we have the setup role where we can assign the default to the message.sender. Keep in mind, if you do anything with message.sender in the constructor, it is going to be the address who deployed this contract. And that is basically how you can add custom extensions on top of your base contract, as well as some custom logic. So currently we have this write note custom logic and overwrite notes which an admin can actually remove. So this is just to prove a concept and to show the power of ContractKit. It's been super convenient to actually develop this new type of contract. Now that our contract is done, let's follow the following steps. Let's go and run yarn build first, just to make sure that our contracts compile correctly and that we can see the extensions that we now have on the existing contract. We can see that we have successfully added the permissions as well. thirdweb's pretty cool and makes some suggestions as well. But now all that's left to do is run yarn deploy. So let's go and run that. Something magical is going to happen right now. It should open the browser, and this is the magic. We are going to deploy this purely without sharing our private key because we're going to do it with this thirdweb flow. So wait for this to compile and upload the contract data, and then we'll do the next step. And now automatically this link will open up. If it doesn't happen automatically for you, you can just simply click on this link in the terminal. This is a once-off deployment step, and as we can see, thirdweb is detecting all the extensions that we are using. How great is that? Before we fill in these fields, these parameters, let's go ahead and connect to our wallet. We are going to connect, and I'm going to personally make sure that I am on the girly test network. At this point, you can select whatever network you want to down here, but I'm going to do this on the girly. Now, let's go ahead and fill in some of these parameters. For the name, I'm going to say this is my eyeballs. And for the symbol, it's going to be maybe EBS. The royalty recipient is basically an address who wants to receive the royalties. For that, I'm going to just simply copy my address and paste it in here. The royalty BPS is a number, and you have to understand how this works. If you place 1,000 BPS, it means that the royalty percentage would be set to 10%. 500 would be 5%. So I'm going to choose 200, which is 2%. And then for the primary sales, you provide another address, and I'll make it the same as the royalty one. Make sure that you have ticked this on if you want this contract to show up in your dashboard. Then you can go ahead and, like I said, select a network. Now you can actually select quite a few networks, and this is because they run on the EVM blockchain. For us, I stay with Ethereum for now, so I'm choosing the Ethereum test network girly. But if this is your real project, then you can do it on the main network. For now, I'm going to click deploy. And this will trigger 2 transactions, which I'm going to sign and say confirm. And we'll wait for the second one. After this process, the contract should be live on the blockchain, on the test network in this case. But this is a really fast and innovative way of deploying contracts, in my opinion. I think it's great what the thirdweb team is doing. So while I'm confirming the second one, let's give it a second for it to fully complete. There we go, it is complete and it's on the blockchain. It is on the test network, however. If I copy the address and go over to girly.ethereum.io and I'm going to paste this in, we should see the contract. Now, no NFTs have been minted yet because I'm using the lazy minting feature. However, back in thirdweb, we can actually go and see all of the functions on my contract. And if I scroll down, here is the right node custom logic that I've added as well. This is a very cool way of interacting with your contract, and it will show up on your dashboard right now because you left that tick box on. We can see with this banner there's some actions that we can now do. However, keep in mind that I'm not going to go over all these tabs because we have covered this in full in the Create an ERC 721 NFT drop. This is technically exactly the same. The only difference is that we have changed the introduction part where we have added custom logic and used ContractKit. I am going to show you how to upload some NFTs and set some claim conditions because we need this for the next part of this series where we are going to build out a minting dApp using the React SDK. So the next thing for us to do here is to physically add the NFTs. How we can do that is by doing a batch upload or single upload. So I'm going to try batch upload because this is what I showed you right in the beginning, these prerequisites to get the images and JSON metadata ready. And I have them over here. So now let's opt for the batch upload. I'm going to upload all 10 images and that metadata file at once. There are various ways you can do this, but what I'm going to do is simply select that folder, highlight all my images, plus the metadata file, and click on Open. At this point, I'm just going to simply verify that the metadata and the images do align. So as we can see, this is a blue eye, and I can see, well, purplish, and I can see it's purple. and here it's yellow, so it looks fine. I'm going to go down and click on Next. We then get to select one of these two options: reveal the NFT directly after it's minted, or have a delayed reveal, hiding it with a hidden image until a later date. You can choose whichever one. I do cover it in the previous video of the ERC721 drop. For now, I'm simply going to go for the option where we reveal the NFT immediately. So let's wait for this to be uploaded to the decentral storage, and then we'll sign our transaction. So let's say yes, confirm. And once this is done, we should be taken back to the dashboard and we should see the list of our NFTs. And there we go. So we can now see that we have a total supply of 10 NFTs that we have uploaded with the batch upload mechanism. We have not claimed them, they are still unclaimed, and to enable someone to come along and claim some of these NFTs either for a fee or for free, we need to set up claim conditions. And that is what this orange banner is telling us. We can also do it by going to the claim condition page and adding a claim phase. Click on there, and then we can fill in these parameters. The fields on these phases are very straightforward, and we've covered them numerous times in this series. But just once again, the first field tells you when you want this phase to start in your local time. So you can set that for a future date, but in my case, I want it to start immediately. Then the cost of an NFT. I'm going to make this 0.05, and the currency would be in Ether. Here we also see how many NFTs do we want to drop in this phase. Keep in mind we have 10 NFTs available, so I'm going to drop 3 of them in this phase. For the next field, we get to specify who is eligible to claim this NFT during this phase. Now, I'm going to select any wallet, but alternatively, if you have a whitelist of only specific wallets that you want to claim, you can select this as well. I go over this in detail in the ERC721 drop in this series, and it's a bit more involved, but you can do that as well. I'm going to leave mine to any wallet. For the last 2 fields, how many NFTs can be claimed per transaction? I would say 1 is a good amount. And does a user have to wait an amount of seconds before they claim again? I don't think that is necessary, so I'm going to leave it to 0. Once we are happy with our phase, we can go ahead and save it. This action will require us to confirm this as well. And once it's complete, our claim phase should now be set in place. This means that the contract was altered and is ready to kick off once the time is reached. So basically this time, according to what the time is right now, is this claim phase is already open for me. So I can go ahead and try and mint or claim one of these NFTs. Great, so we have now claim phases set up. Our NFTs are there, ready to be claimed. But the biggest question is, how does a user go and claim one of these NFTs? I mean, they can go to Etherscan and do it from there, much like our Explorer, calling the claim function over here. But this looks so complex. And you're right, we need to now build a minting dApp, making use of thirdweb's React SDK, as well as the UI components, to build a small React dApp for a user to interact with this contract in a nice UI-friendly way. And that's what we are going to do in the next video. And not only will that video help you out to understand how to build a normal minting dApp, but I'll also show you how we can interact with our custom logic as well, making thirdweb's SDK really useful for any scenario. So that will be coming up next. On a last note, if you worry about not finding your dashboard again for your contract, all you need to do is click on the thirdweb's icon, or go to the dashboard, and if you are connected with that same wallet, you will find it over here. There is our eyeballs contract. So you can simply access that by clicking on it. And there we go. So, I really hope that you enjoyed today's tutorial and that you learned a bit more about the ContractKit from thirdweb. If you did, let me know in the comments what you want to see next, and also remember to subscribe so you don't miss a moment. I really had a lot of fun and I'm looking forward to the next video, so I'll see you over there. Cheers for now, have an amazing day.